as a supplement to the lecture that never was, we're going to go through two questions, a relatively shortish one looking at right here, and then we'll look at another one from our online homework that's a limiting reagent calculation, and we'll look at that one in at least two different ways, maybe three different ways. So we'll go ahead and get started right away with this one. If we want to follow the process, and because I'm doing it, we do want to follow the process, what we want to do is identify what we're trying to solve for. We're solving for atoms of hydrogen. Okay, we're not going to call it H2 because it's not asking for molecules of hydrogen. It's saying very specifically atoms of hydrogen. So we know we're looking at a single atom. The next part we could go through and identify is what we were given. So because we're only given one thing, we could probably make a safe assumption that that one thing needs to be in the numerator. If you don't like that, that is okay. And what we could do is change our focus. And I guess we'll do this one in a couple different ways too. And we'll change our focus in a second. So 1488 grams and then over 1. So now what we want to do is definitely set up a conversion because grams of phosphoric acid is not the same thing as atoms. And so ideally, what we would do is this conversion. I want atoms of hydrogen, so I'm going to place that in the numerator because that's where it appears. Come on, pen. Where it appears in my answer. And I don't want what I was given, the grams of H3PO4. Okay, so this way, by placing it, those units would cancel, and then I'd have the atoms of hydrogen that I wanted for an answer. And so what we're supposed to do as soon as we establish this conversion factor is then ask, does this exist? Okay, if it exists, then great, you can now drop in numbers into the expression. If it doesn't exist, we now have a problem. Okay, so again, we would now try and think, does this exist? This is where I would recommend the tutoring center and getting their mole wheel sheet. Not for the mole wheel, but at the bottom it lists all the conversion factors that we would possibly have. And we don't have a conversion factor that relates grams of one substance to atoms of another substance. Okay, so if we go through and think about our conversion factors or classify them, what you'll find is our conversion factors really break into two kind of categories. We can look at converting one measurement, call that one measurement, into a different measurement. So measurement 2, so grams into moles, kilograms into grams, miles into even time. Okay, those are conversion factors where you're converting the individual measurements. The other conversion factor type that you have is from substance 1 into substance 2. We don't have any conversion factors explicitly provided that allow you to convert measurement and substance simultaneously. So when we go through and look at this conversion factor that we've got atoms as one measurement, grams as another measurement, and then we also have hydrogen as one substance and phosphoric acid as another substance. That means we have to run at least two conversion factors. Okay, and this is where things can get kind of sideways, is we have to decide what conversion we want to run. I can either work with the atoms of hydrogen or I can work with the grams of phosphoric acid. Either way we do it, we're going to end up using the same conversion factors. We're just going to place them in a different order. Okay, I'm going to go through and start with the atoms of hydrogen because I'm selfish and I want what I want as soon as I can get it. Okay, so I want atoms of hydrogen. I'm going to have to relate that to something else. And in particular, I want to relate it to my phosphoric acid because I know something about the phosphoric acid. Okay, well, if I'm looking at a potential conversion factor that relates these two substances, the place that I can find it is the chemical formula in this case. Okay, in most scenarios when we talk about chemistry, we would actually be looking at a balanced chemical equation. But we can go back and look at our formula. We can say atoms of H because it's a single atom, and then our phosphoric acid would be molecules, or our MLCS as I write it. How many atoms appear in our phosphoric acid? What's that relationship? Okay, well, if I highlight, come on, pen, I have our H and I have our H. What does this 3 next to the phosphoric acid or in the phosphoric acid mean? It means there are 3 atoms of H in, what's the number appearing in front? 1 molecule of H3PO4. That's what that means. Okay? This conversion factor now allows me to say I can convert the substances. Problem is it doesn't deal with any of my given information. Okay? So I don't get to eliminate anything from my expression. So now that I have what I want, at least, I can start to think about that given information and how I can potentially get rid of it. If I'm given H3PO4, okay, I want that to cancel again because that doesn't show up in my answer. And again, ideally, I want molecules of H3PO4. If this conversion factor exists, then hell yeah, I can plug in the numbers and I punch it in and I'm done. The problem is that grams is a large measurement, molecules is a small measurement. Okay? So there isn't a clean conversion factor between grams and molecules for an individual substance because they're at different scales. Molecule is incredibly small, grams is incredibly large, relative. Okay? So this conversion factor, again, does not exist, so I have to decide. I have to, again, make another decision. What conversion factor do I want to deal with? Okay, I already made things messier by including a conversion, that formula conversion that we have in front, okay, by not getting rid of units. So I'm going to focus on trying to get rid of the gram unit. So this way I can potentially cancel it. So what do I want to convert that grams to? Again, I can convert it to anything I want. And with experience, okay, again, if you reference that table of possible conversion factors on the green sheet, okay, from our tutoring center, okay, what we would find is that going to moles is a valid conversion. That conversion factor off of our green sheet is found on the periodic table. I conveniently didn't have a periodic table handy, and I can't do that math that quickly in my head. So we're going to pause for a second. No guarantees that I didn't screw up the calculation in my calculator because I did it really fast. But what we would say is we have 3 times 1, officially 0.01, if we're looking for the mass of our hydrogen. The phosphorus, there's 1 phosphorus times, I've got the number in front of me, and I already lost it. Officially 30.97, and then we've got our oxygen, which I'm writing as oxygen. Instead, we should say we have 4 oxygens, each of those oxygens coming in at 16.0. We add all that up, and I think, again, assuming I did the math right, we come out about 98. That is the molar mass, which means that 98 is grams per mole. Okay, that does not mean the grams goes, or the 98 goes on top. What it means is the 98 needs to go next to the unit it appears with, which is closest to the grams. I'm going to place my 98 here. I'm going to place my 1 mole up there. What does this do for me? My grams of phosphoric acid cancel out. That's fantastic. I've introduced yet another issue. Okay, remember when we started this, we needed at least 2 conversions. We had to convert the substance and the measurement. We've converted the substance, so we still have an issue with our measurement. Okay, so now we've got to look at it and run another conversion to clean this up. I don't want the moles of H3PO4, but I don't want the molecules of H3PO4. Both of those units should cancel. Just like we did with every other thing, we're writing out what we want as quickly as possible. Can I do this? Does this conversion factor exist? This would again be a good opportunity to go back to that sheet that summarizes all of the possible conversions and say, does it exist? Does it? Yeah, it does exist. That conversion factor is Avogadro's number. What does that mean? 6.022 times 10 to the 23rd things is equal to a mole of those things. Okay, in chemistry, things are molecules. So we're talking about 6.022 times 10 to the 23rd molecules is equal to 1 mole. What happens with our units? Moles cancel. Where'd they go? There it went. Molecules of H3PO4 cancel. I can now go in and punch it into the calculator. 6.022 times 10 to the 23rd times 3 times 0.1488 divided by 98 and I now have the molecules of hydrogen atoms that are found in this mass. Okay? This shows that whole process, and again, each of those inflection points, I guess we call them inflection points, every time we brought in a conversion factor, we asked, does it exist? Does it exist? Does it exist? So you have to know that content. Okay? Deciding whether that conversion factor existed or not is what drives your calculation. So that's where you need to be focusing and how you deal with this. Once you've got all of this work written out, okay, note there's some important work shown here, like the conversion factors, units canceling. Also, where did I get the conversion factors from? Okay, all of that is important information for your work process so that when you go through to solve, you can solve consistently and you can understand how and why you got those conversion factors. Okay. Again, you see something slightly different, you're going to change the order in which these conversion factors appear. Now that we've got our answer, what could we go through and do? We could now go back into, what is this program? Active, and we could start plugging in our information. Okay, I'm not going to go through and plug it all in, but Active sets you up with this kind of left to right format, as opposed to the solve that we went through and did, which was right to left. Ultimately, you look at the answer, it's still going to come out to be the same. It doesn't matter how you format it because it's all multiplication division. What matters is where you're placing the units as you navigate. Okay? In our conversion, we had the given information and we had 3 conversion factors, which means I need to add 3 conversion factors. If we zoom out, okay, apparently I can't zoom out very well, we could go through and start to drop in all of our conversions or all of our things, our grams of phosphoric acid. I honestly don't remember all the conversion factors that we dropped in there. Okay, we could say we need to get rid of grams, moles, that was our molar mass. I need to get rid of the moles of phosphoric acid. What do I want to convert the moles of phosphoric acid to? I want to convert them to molecules of phosphoric acid. Okay, the molecules of phosphoric acid I need to cancel, and I want to bring in the, where did it go? The atoms of hydrogen. What happens is I would solve for the atoms of hydrogen. Note, in this process, everything that's written up here, what do you not see? There are no numbers. I cannot stress enough how important it is to focus on the units and ignore the numbers until you have a valid conversion factor. If you're seeing anybody writing numbers, it's because they've already memorized how to solve the question. Okay, that's it. They know the answer, therefore they can show the work. That's a stupid process, and it is completely and utterly moronic. Yes, I'm calling anybody that wrote that out that way a moron, including myself, because I've done it like that also. It's only when we start to realize what we know and versus what we don't know that it becomes really important to leverage following the units. So please, please, please pay attention to the units. Let the units dictate your calculation, not the other way around. Okay? I'm going to pause. In this particular problem, I know, big shift, apologies. We talked through a process in class on how we set this up. We talked about the bread, the sandwiches, and all that fun things. What we've got here is effectively that same situation. Of course, I lost my color coding. We've got bread, and we have cheese, and what we're trying to decide is how many sandwiches, the grams of NO, that I can possibly make. Okay, same process as we looked at before. Okay, this is going to get a little bit more complicated because I have to run that process that we just went through and did for that other question with the bread, and then I also have to run it with the cheese. Okay, in both cases, what I'm trying to do is ultimately get the bread and the cheese into a space where I can make a fair comparison. In the previous actual lecture that we had on this, I'll link to the video, we went through and solved this in gory detail, getting all the way out to the grams of NO, our sandwiches, as our final process. That involved lots and lots of individual calculations. There are other approaches to this that don't require you to go through all of that detail, sort of. Okay? Remember, we said the biggest or the most important aspect was to get the units of our bread into units of our cheese so that we can make a fair comparison. Okay? And that fair comparison is ultimately coming through our chemical equation, okay, or a recipe. In the case of our sandwich, we need 2 slices of bread plus 1 slice of cheese to go through and make our one sandwich. Okay? So what could we try and go through and do to help this kind of process along? Well, I could try and set this up and decide which one is the limiting reagent. In the previous case that we went through in the other video, we went through and converted all of my 25.0 grams of NH3 into grams of NO. Okay? We then went through lickety-split and converted all 45.0 grams of oxygen into our grams of NO. We then said whichever one of these two numbers was the smallest was the most product I could make. Okay, and that tends to trip people up. You're like, well, if it's the smallest, why is it the most? Because you've run out of that ingredient. Okay, if I only have 1 slice of bread, okay, I can't make a sandwich. Even if I have 50 slices of cheese, okay, I still can't make that sandwich. It's the smallest number that dictates the most product. Okay, so what we're going to do here is tweak this calculation, because if you remember from that video, we had to do a whole bunch of conversions in those individual processes. Okay, so what I'm going to switch this up to do now is I'm going to take the grams of NO, and instead of converting into the grams of NH3, and instead of converting into grams of NO, I'm going to convert into grams of oxygen. Okay, and we'll see why here in a second. 25.0 grams of NH3. Okay, and I hate drawing it out this way, so I'm going to have to switch back to my format. I want to know the grams of oxygen. The given piece of information I've got is grams of NH3. So what I'm asking here is, how do I convert my 25.0 grams of NH3 into grams of O2? One of the common questions you'll hear me ask is, why did I place that grams of NH3 in the numerator and not in the denominator? Because the substance is different, right? Why am I allowed to do that? Look at the measurement. The measurement unit is getting placed in the exact same location. Okay, so now we could set this up. I know I don't want grams of NH3. I want grams of O2. Does that conversion factor exist? No. Okay, because it doesn't exist, I'm going to have to convert that grams of NH3 into something else. I'm going to choose to convert it into moles of NH3. Where do I find that conversion factor? That conversion factor comes from the periodic table. Nitrogen is 14, hydrogen is 1, so we're looking at 17 grams, assuming I did that math right, of NH3 is 1 mole of NH3. Now what can I go through and do? I want to get rid of the moles of NH3, and I want to bring in the moles of O2, because I need to get the substance of O2. Ideally, scratch that one, I want grams. That's changing the substance and the measurement. I'm not allowed to do that. Okay, so to do that, I now need to bring in moles. Where do I find the conversion factor between moles and moles? That's going to come from my balanced chemical equation. That's the coefficients straight off the equation. So there's a 4 in front of the NH3. There's a 5 in front of the O2. Those measurements from our chemical equation are moles. That's one of the powerful things. So this conversion factor is coming from our balanced chemical equation. Several people have been trying to use chemical formulas to set up conversions, and that's ultimately because the examples that we worked through allowed you to use percentages of atoms in a particular formula. The formula was incredibly simple. That process that you've gone through and done, 2 people have done it to my knowledge, fails miserably here because there is no O2 in NH3. right? That relationship only comes from the balanced chemical equation. We want a process that is consistent for all solves. What happens? The moles of NH3 canceled. I forgot the grams of NH3 also canceled. I now have moles of O2. I don't want moles of O2. I want grams of O2. Okay, how do I figure that out? That comes from the periodic table. Oxygen weighs 16. There's 2 oxygens. This gets me 32 grams of oxygen is 1 mole of oxygen. And now I'm going to do a sneaky pause. Maybe again. So I did some work, punched it into the calculator, and I find out that I need 58.82 grams of oxygen to react with 25 grams of NH3. Okay, that's what what I was able to run through this calculation. How is this valuable to me? Well, if I have 25 grams of NH3, I need ballpark 60 grams of oxygen to react all of the NH3. How much oxygen do I actually have? How much I actually have was 45 grams of oxygen. Okay, what does that mean? That means oxygen is my limiting reagent. In this case, cheese is going to limit the amount of sandwiches. Okay? Because the bread, I need even more oxygen than I have. So I can't convert all of the bread across. So what does this mean for me? The calculation that I've run here to answer the question that was asked gets me halfway at best. Okay? This calculation allows me to know what one was my limiting reagent. My oxygen limited the chemical reaction, but it doesn't tell me the mass in grams of the NO because I don't have that unit yet. So what I now have to go through and do is I would repeat this whole frickin' calculation process, but now I want to say, well, how many grams of O2 did I start with? 45.0 grams of O2, and I now want to convert that into grams of NO. And I go through the whole process again, grams of oxygen, moles of oxygen. Okay, that's, 32 grams is 1 mole. I need to get the moles of O2 to convert into the moles of NO. That conversion factor comes from the balanced chemical equation, 4 and 5. I need to get the moles of NO to turn into the grams of NO, which comes from the periodic table. 14 and 16 is 30 grams of NO is 1 mole of NO. Now I can run the calculation and I have my answer of grams of NO. You're like, well, that's roughly the same amount of calculation work that we did with the last one. You're right, it is. Okay, but the question that's being asked was different. Okay, the point of running our first calculation was which one was the limiting reagent. I don't care to get to grams of NO. I'm being asked a different question. So depending on what you're being asked, you can change your format for what you're trying to solve for. In some cases, it makes it look like you're doing less work. Ultimately, you're going to do all of the exact same amount of work within some slight variations. Okay? So one option that I've seen people do is that they stop, instead of going to the grams of NO, they go to the moles of NO. Okay? And they do that for the oxygen, and they do it, so our cheese, and they do it for the NH3, our bread. Whichever one was the smaller number, they convert that one into grams of NO. You saved one calculation at most, okay, to go through and do that. How much time did that really save in the grand scheme? Next to nothing. If you're following the process, you should be fine all the way through as far as time, and you're maybe taking 5 seconds more. That's it. Really not a big deal. But it is going to come down to the question that's asked. If you're asked for the limiting reagent, you can do a direct comparison of the bread to cheese. If you're being asked for the amount of product, you should just convert bread and cheese into the product. Right? That's just the logical flow of how you want to set things up. Okay, that was a real fast walkthrough on both the limiting reagent and on that other conversion. Hopefully this helps. If you've got questions about it, I think I'll put it in as an announcement, maybe even post it as a discussion board. So if you've got questions, you can post questions into the discussion board. If you want to show your work for how you went through and solved it and explained it, I have no problems going through and trying to address that as well, particularly because we missed the lecture. I appreciate that you spent the time to actually watch this lecture. Hopefully it was useful because it was really fast. With that, I hope you have a good weekend, and we'll see you on Monday.